some stuff down. I've got some questions to answer. Question number 1. What position is the object at T2? Well, T2 means time, and 2 is the second. So at T2, it's asking me, well, what position, what location, what distance is it located at? I hope that everybody came over here and said, oh, all right, well, let's go this way, and we can see that it's at 2 meters. So double check your answer. Again, if you got the wrong answer, not a problem. You just need to try. And if you need to, then show your work. If it's a question that you need to show me your work. Now, question number 2. Question number 2 says, what is the speed of the object? Whoa. Okay, this was at T2. This is also at T2. But this one wanted to know position or the distance. This one wanted to know the speed. And don't forget, a dt graph, rise over run, is going to be my speed equation, d over t. All right. Well, I'm going to come over here and I'm going to say speed equals d over t. Hopefully you or someone helped you out, or you did this on your own, and you got, well, the distance is 2 meters and my time is 2 seconds. So some of you may have 1 meter per second as your answer, right? And you gave me that SI unit because all numbers have no value unless they have a unit with it, hopefully. Question number 3, what is the speed? Okay, they want to know speed again, but they want to know the speed of the object at T5. Okay, Chris, what'd you get for T5? Because at T5, speed equals d over t, and definitely t is 5 seconds. And at this location, distance is 4. Is that what you got, or no? Why not? Because it's at rest. Okay, I want to pause for a moment real quick with everyone. When it comes to DT graphs, you're looking at an average of what's going on for that whole section. And so kind of like what Chris said, okay, at this T, which was T5, yeah, you could, because I do have some students that say, oh, the distance is 4 meters, so 4 divided by 5 is my answer. We're not just analyzing that instantaneous moment. We're analyzing this whole line. And this whole line from here to here is at rest. I agree with him. And there is nothing going on. Hopefully you wrote, if you didn't, go ahead and write it in, 0 meters per second because it is at rest. I agree 100%. Okay. So now it says, wait a minute, what about T7 or at 7 seconds? So let's go over here and look at where 7 seconds is. When I look at 7 seconds, it's regarding this line for line C. And line C is not a flat horizontal line, so there is going to be an answer. Okay, not a problem. Let's pick on, we're going to go with that Logan, not this Logan, that Logan. That Logan over there. Let me zoom it out just so that way everybody can see. So let me, for question number 4, come over here. Speed equals d over t. What'd you get for d, Logan? 3. He got 3. What'd you get for, oh, well, and t is 7. What'd you get, so what's 3 divided by 7 then? Right, because isn't t 7? So what's, oh, whoa, whoa.
I did it over the slope. I was finding that slope of that line.
Okay, so, okay, hold on one moment. Let me make sure I understand what he's telling me. You did not do this. Is that what you're telling me? No. Okay, not a problem.
3 over 2.
He did 3 over 2.
I did the distance of that line. Yeah, I did rise over run of that line.
Say it again.
I did rise over run of the line.
Okay, so let's pause for a moment. Here's the problem. Thank you. I think I picked on a good person for that one. What Logan said he did was, he said, well, Miss Munson, it asked me regarding T7. But you remember a minute ago, I just asked Chris, hey, Chris, you sure you didn't put 4/5? And he says, well, no, because that line is at rest. Chris sat there for a moment and he analyzed the whole section of the line, which I agree 100%, yes. Question number 3 is 0 meters per second. And Logan, I was trying to mess him up for a moment, but he's like, no, Miss Munson, you can't catch me. I didn't do that. I did not come over here and say at T7, I went up and said, oh, that's 2.5 or 3 meters of a distance. He said, no, I analyzed the whole slope of the line. So in that situation, I'm going to come over here, Logan, I'm going to put an X on this. He analyzed one more time the whole slope of the line. So what is the whole distance that it covered? Or what did you put for D?
A 3.
A 3? And what did you put for the T? 2. So what's that answer? 1.5 meters per second. That is the correct answer. I hope you got it. And if you didn't, not a problem. It makes sense now. Oh, I was just thinking that we were just looking at T7. No, T7 is part of the whole line C. Does that make sense? And so you needed to analyze the slope for line C in general. So I agree 100% on that one. Let's keep going. It says here, during which time interval, it says, was it the greatest? I hope you got letter E. To do that, you had to kind of look to see, for here, 0 to 4 is 4 seconds. This one was 2 seconds. This one was 2. This is 2. 10 to 11 was 2. During which time interval was the speed the greatest? And then this one over here was 1, 2, 3. So I have my T's. Now all I have to do is come over here and analyze my D and distance over time so I can figure out which one, or let's be honest, with your eyes you kind of can tell which one's the steepest slope, right? So the correct answer is E. Let's keep going. Which ones are at rest? We have already analyzed that, B and D. We've already analyzed that one. Number 7, during which interval of time does the object move the greatest distance? Well, line F from here all the way over here, which was a total of 8 meters. Let's keep going. Number 8. Number 8 here says, whoa. Where am I at? I think I messed up. Number 7. During which intervals of time is the object moving towards the origin? Not only F, but it is also C and F. Forgive me on that one. I was reading number 8. During which time interval does it move the greatest? That is F. That is F. Number 9, what is the total distance moved at the end of 14 seconds? Oh, I like that one. Now, if they asked you what the total displacement was, that would be 0. But they asked you total distance, so you had to add each of these lines up to see the total distance. Hopefully, you got the total distance of, tell me if I'm wrong, 22 meters? 22 meters, right? And then the last one says, oh, wait a minute. What is the displacement? And that answer is 0 meters. Not that it did not move, but that it moved back to the origin or back towards home. All right? So just double checking on that one. Now I'm about to turn the page because this next question is going to be really helpful on the quiz in just a moment. There was only 3. That's it. 3 questions over here. You've got one very similar to this on your quiz in just a moment. I'm going to zoom in. First thing you need to do is when you look at graphs, you need to analyze, is it a DT or is it a VT graph? Well, this is a DT graph that they gave me, but I need to analyze the VT graph, okay? So hopefully when you did this, you've got, I don't know, maybe this part of your notes out. So I'm going to keep this part of the notes so that way we can refer to it. I'm trying to draw this graph as a VT graph. Oops, VT graph, and this is a DT graph. Okay, well, no, they didn't give you little tick marks and stuff. They didn't give you T over here, but you could come over here and say this is, square 1 or time 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I can see that. What they did do, I like this. They gave you the 0, and that is going to be your x-axis. That way, because on VT graphs, the majority of the time it's a VT graph, we can have above and below. We really don't have below, to be honest, on a DT graph. But on VTs, we do. So I'm going to come over here, and I'm just going to put a little line right here. I'm not sure if you noticed that. That's where the x-axis is located. So I just wanted to put a little line there, just so that way we can visualize that's the x-axis. Over here, though, this is actually the x-axis. This is the x-axis. This is the x-axis, all the way down here on the DTs. And you can see it on the VTs, and they have it right here. Okay? So there we go. Let me zoom in a little bit. Okay, quick reminder. On VTs, above the x-axis is the wave. Below the x-axis is moving back towards the origin. On DTs, you can have curves, but on VTs, you cannot have curves. There are only nice slopes or horizontal lines. On VT, a flat horizontal line above or below means that my object is moving, but it's moving at a constant speed. On a DT, if I have a slope, whether it's direct relationship or inverse, then that means that I am moving at a constant speed. But on a DT, if I have a curve, then that means now that I am accelerating, decelerating, okay? A slope on a VT means you're accelerating or decelerating. So now that we've got that in our head, let's go ahead and analyze. Here's what my first step would be. I would come over here and I would say, oh, at rest. Oh, at rest. And then I would say, constant speed. Back towards the origin because it's an inverse line. And then I would say constant speed away from the origin. Okay? So now let me go ahead and let me simulate and replicate that as a VT. But I'm also going to come over here and I'm going to say this line A took up 1, 2, 3 spaces or 3 seconds, whatever you want to call it. So over here, it's going to be at rest on the x-axis, 1, 2, 3. Makes sense? Hopefully that makes sense. Then on line B, it is moving at a constant speed, but on a VT graph, a constant speed back towards the origin looks like this. It's below the x-axis. So now I'm going to come over here and I can see that it moved for 2 seconds. So now I'm not looking to see that you moved this much. I just want to know that you did it below the x-axis. I'm just going to say 1, 2. Then line C is at rest again, but it's at rest for 1, 2, 3 seconds. Okay, 1, 2, 3. Literally, Miss Munson, it's going to look like that. It does. It's like all over. Like here, there, here, there, here, there. Then VT graph. This is for 1, 2 seconds. And it's moving at a constant speed away from the origin. And don't forget, constant speed away from the origin is a flat line above the x-axis. So where you put it, I personally don't care. I just want to see it above. Now, if you feel like in your gut that I want to connect my lines, this is how you connect your lines on a VT graph. You just go here, drop, go straight, come straight up, go straight across, straight up again, and go sideways. Hopefully that's easy cheesy, and now you get it. We needed to practice this. Let's practice again. Oh man, well, now when we practice again, this one over here is a VT, and I need to create a DT that matches this VT. Again, step number one is I would analyze what's going on, but don't forget, these lines right here is just connecting line A to line B. That's what this straight up and down line is. Other than that, it has no significance. It's just connecting this A to this B. So now I need to analyze. And the easy one is I can see that is at rest. And then I can see a flat horizontal line is below. So constant speed back towards the origin. And above the x-axis is constant speed away from the origin. Okay. Again, though, I'm just going to go ahead and replicate the amount of time. So this went 1, 2, 3. This took 3 seconds. 1, 2, 3 seconds. And then this one was the last bit of it, or the last 4 seconds. So let's go ahead now and create that over here. Constant speed away, if we don't recall, that looks like this, a direct relationship line. Then it shows me that it moved at a constant speed back, an inverse relationship line, and then it's at rest. Where at rest, though, Ms. Munson? Doesn't matter. Wherever you want to put it, right? So let's go ahead and let's do a constant speed away. For 3 seconds. A constant speed back for 3 seconds. And then if you wanted to, I don't care where, as long as you have a flat horizontal line, that's it. That's what I'm looking for. I'm not looking for exact location and position. I'm not asking you to analyze it because they really don't have any speed or speed numbers here or distance numbers for me. I mean, I can make them up, but I'm not asking that from you. That's what you should be able to draw. Let's do the last one over here. They told me that there's 3 lines to analyze on this DT graph, okay? You've got to create it on a VT graph. So if there's 3 sections of the lines, then there should be 3 sections over here. Well, the obvious easy cheesy one is going to be this one that's at rest. Okay? And that's like about the last 3 seconds right here. And we know that that is going to be on the x-axis over here. Then we can look and analyze the next super easy one, which this one is constant speed away from the origin. But then there's that curve. Remember, you can have curves on DTs, but you cannot have curves on VTs. Okay. Just in case if we're not sure, this curve right here, it looks like this. Nope. Does it look like this? Nope. It looks like this. It's slowing down or decelerating away. It is slowing down away from the origin. Okay? Whoa, what does that look like over here? Slowing down away from the origin. It's going to be an inverse line above the x-axis is what it needs to look like. Okay? So now I'm going to move this out the way. A constant speed away. Away is above the x-axis. So in that situation, we're going to go from here to about here, which is 1, 2, 3, 4.5. 1, 2, 3, 4.5. I need to make a constant speed away, which is going to be above the x-axis. 1, 2, 3, 4.5. Hopefully you agree with me. Tell me if I'm wrong, but it should be a flat horizontal line. It is moving, it's just moving at a constant speed. But now we have deceleration occurring. And a deceleration line, or slowing down away from the origin, is going to be a downward inverse slope. And then it goes into a rest. Goes downward slope, and then it's going to go to rest. And that's what it should look like. I mean, again, depending on how high up you went, I'm not looking for that. I'm okay, and you're about to do one on the quiz. So this was a really good homework. Any questions regarding this? I really thought it was good practice. Other than that, we've gone over all your